Hey everybody, Dawn Zoldai here, CEO of P3 Tech Consulting, and I'm here today with Amal Parikh from Doodle Labs. And today we're going to talk about their multi-band mesh radios and how they unlock improved connectivity and new territories for flying robots and ground robots and so much more. So, Amal, welcome.
Thank you so much for having me. I'm really excited to be here.
Absolutely. And I think we have a really cool video to roll. Such a great video. Amal, so much going on there. And I love to start talking first about the problem statement. In other words, with your mesh radios, what problem exactly were you trying to resolve with regards to traditional ways of radio links and connections?
Yeah, absolutely. So with that, it probably helps to just say a little bit about who we are at Doodle Labs, and that's exactly why we do it. We design and manufacture industrial grade wireless networking solutions for all kinds of scenarios. We really cut our teeth producing radios for long range mesh connectivity in all kinds of robotic systems like drones in the air, robotics on the ground, quadrupeds, etc. And then recently, actually, we also stepped into having a handheld version of that radio, which actually works within that network, robotic network, or in a fully handheld distributed setting for connected workers. Our idea is really that improved connectivity leads to safer and more efficient work. We believe in the future where robotics plays in with industrial work done by people, and we want to give that solution that makes that something that is actually possible.
Well, before your radio, how did it used to work when selecting a radio to be used with a robot?
Yeah, well, there was actually, and there continues to actually be quite a variance in that, and it really depends on the environment that the robots are going into. We found that on the drone communication side of things, there has been a step change that has moved towards mesh radios like ours. But on the ground robot side, especially in warehouse, they are still using kind of the more ubiquitous networking solutions like Wi-Fi. But what we find, especially with our customers, is that the use of standard networking technology doesn't hold up with these really advanced robotics. When it's really important that it's super low latency, really reliable, so you don't lose connectivity with that robot when it's doing its work. And so that's actually where I find most of it has been. And then even the ones that have moved into mesh robotics, again, on the drone side, it seems to, the fact that they have to go really long distances and the unique aspects that they have to work again, like, has already moved them to this advanced technology. It has mostly been in a single frequency band. That's just where technology has been. Even our legacy products have been in just one frequency band. So that's where we're really excited to talk about multiband and what that unlocks, because we see it as the future. We see it as something that becomes just another tool in the tool belt for our customers as well as their customers in the field.
So, how does the multiband mesh rider radio actually work then?
Yeah, well, what we've done actually, and it takes a step back going to how we developed it, right? Where we started with our products for drones in general, again in the single frequency band, and we started to see that improved connectivity for those customers, and I think that started to be noticed in the market as well. So a few years ago, DIU approached us. Um, to work with them.
And DIU, just for everybody out there, they probably know, but if you don't, it's a Defense Innovation Unit.
That's right. Thank you. As they were really spinning up the Blue UAS program, which is a great program that we're really proud to be a part of, that has helped consolidate and organize a lot of the technology and the requirements for drone manufacturers, especially here in the US. It starts from a government side and moves to commercial as well, as it seems to really be setting the standards. We worked with them to develop our first multiband radio that we call Helix, that covers 6 adjacent frequency bands from 1.6 gigahertz to 2.5 gigahertz. They designated the bands as like M1 through M6. And that covered the full range that they needed for that program. We were able to do that in a very small form factor and have those 6 bands in this one little radio.
I mean, that's so small. I'm looking at it, Amal, like, is that like smaller than the palm of your hand? Look at that.
It is. It is.
Wow. Okay.
I'm looking around for a comparison. I have a little AirPods.
Oh, okay. That's a great comparison. I think so many people have those little iPods cases, and this is
Yeah,
actually about the size. Yeah.
yeah, and low swap being such a consideration for drone applications in particular. The smaller your components, the lighter weight, the less power it uses. That's just more battery life available to the drone for its mission. And so that low size, weight, and power consumption, that's what we had as a design constraint, as well as offering something that could cover those 6 frequency bands that they needed. And we could have approached it as kind of how we had before, where we maintain our form factor and our footprint, but we had offerings in one single frequency band per radio. It was still something that we were offering because it really simplified the integration process for a drone manufacturer if they wanted to operate in one versus another frequency band. And this could be based on a customer requirement, based on a geography that they're going to deploy into. So many different reasons why they could choose a different frequency band. But what we saw was the ability to actually put all of them in one radio went a lot further. It completely reduces that requirement for integration work, and it also allows them to start to now have a lot more tools again in that toolkit to avoid interference.
Well, you've employed this and integrated with a whole host of different companies, Amal, and I think we have a really cool video with FreeFly's Astro, and I'd like you to kind of talk us through this a little bit about the different commercial, government, defense, and dual use cases.
Yeah, absolutely. Yeah, so what you're seeing here is the FreeFly Astro, an amazing platform, and what they're actually showing is kind of how it's being used in a lot of different ways, in a lot of different environments. That's really the thing to take away, where a drone system is created and it's built for maybe a handful of use cases, but people are so creative of how they bring it to market, what they're using it for, like a bridge inspection over here, agriculture, all kinds of different stuff. And so FreeFly has done a really great job, even in cinematography, of approaching the commercial industrial market and providing a great platform for them. What we've developed along with our multiband technology, initially that was that Helix configuration that covers a lot of federal frequency bands. We moved into having an offering now that actually covers the 2 unlicensed frequency bands, 900 megahertz and 2.4 gigahertz, together in one little radio. And that's what we're working with the guys at FreeFly to use, because what it allows, again, goes back to that interference optimization point of view, where you could be flying and in that area of operation or that mission that you're in the field, With our radios, you can do a spectrum scan to start and see what the noise level is like in the area. You can fly with the first or whatever frequency band looks the best at the time. But often they're going such far distances, as you're seeing here. You could go over a pocket of like an urban area or something like that where you're starting to hit a lot of interference in the one frequency band. And so as we've developed further into our mesh rider technology, beyond just having the multiple bands available to you, we've developed some intelligence to actually avoid or optimize for that interference. And so if you're seeing that, say, in the 2.4 gigahertz, and that's what you're flying in, you have the ability to, within the band, move over to a different channel that is less occupied, less noisy, or altogether switch to the 900 megahertz frequency band and have that cleaner signal. And so the whole thing is really trying to give our customers and the people in the field just a more reliable data link. That information they're getting from the drone is what it's all about. Having that in real time and low latency, we just want to make sure that that's something that is so you can rely on, that you can have and take into any kind of scenario.
Yeah, I mean, so you started with the Defense Innovation Unit on the defense side, now adapted this for the commercial sector, like so many folks do. And you're right, Amal. I mean, just in that video right there, a lot of water I saw, a lot of flights over bodies of water with that expensive drone with incredible sensors. That's something where you want to make sure you have the connectivity, because you don't want to be dunking into the lake there, right? So what you've done is brilliant here, and you have I believe like a two-step process that you recommend for people as we're thinking through what kind of form factor or what's the right multi-band mesh rider radio that they should choose if they're looking to work with you. So step one is choosing that form factor. So tell us a little bit about those form factors that your radio comes in.
Actually, that's exactly right. But if you don't mind, we actually think step one is choosing the frequency, and then step two is the form factor.
Gotcha.
And the reason for that is, again, our customers building their platform are really, they know what they're allowed to use or not allowed to use. And so if they're a commercial customer, they have to stick to unlicensed frequencies. And really depending on where they're deploying or where their target markets are, limit that as well. In the US, we're really lucky that we have both 900 megahertz and 2.4 gigahertz on the unlicensed side available to us. And they're both really great, including areas like Australia can also take advantage of 900 megahertz. But places like Europe or even India, their 9 megahertz in Europe is really power limited, which really reduces that range that you can take it and what you can use it for. And in India, that's not even available from an unlicensed point of view.
I'm learning so much right now, Amal. I mean, I assume that as a customer comes to you, like you would consult with them on this first question about frequency.
Exactly right. It's like one of our first questions. Often they know exactly what they're looking for, or they just know whether they're allowed to use federal frequency bands because they have a government-focused application. Their end users are going to have that license and that approval to use federal frequency bands, or they know that they're making a commercial platform and what markets that they're approaching. So whether they know it or not, often they do, but sometimes they just kind of know which camp they fall into. And we definitely provide that consultation to kind of say where we think they're going to have the best performance, what they can and cannot use. On the federal side of things, again, they really know that usually from the start of what they're allowed to use and what they're not. And even taking further, I mentioned the M1 through M6 Helix versions. We have other ones that are with government and different areas of the armed forces. They have specific bands that they tend to use most. And it allows for just the cleanest and just like they know that they have that band available to them. And being able to use federal frequency bands, I should say, is always great if you can, because you have the least amount of noise. And so they're letting us know what they want. And we've expanded our offering into an L and S band configuration, as well as some others that I can share more later. But anyway, someone will come to us and let us know whether they're government and defense oriented application or if they're commercial. We'll steer them towards the appropriate radios. And that really gets into then form factor, where they're letting us know what type of system they're building. And if it's something that, they're building a robot from the ground up, with multiple configurations that work with that. The one I showed you earlier is the Mini.
Okay.
It's this one here, as you see also on the screen. This is almost all of our radios are 2x2 MIMO, which just basically means that it has two antenna ports, and it uses both antennas, MIMO standing for multi-in, multi-out. So they use both of them to send and receive data. And what that just allows, again, including the intelligence in our Mesh Rider OS, is that you can have that non-optimal signal paths where it's reflecting or having to go through trees or things like that. And you just are able to make the most sense of that, even in non-ideal conditions, which you're basically never operating in ideal conditions. But we do have some customers who are making really small platforms. And for them, those small platforms aren't really going usually such a far distance, but size and weight are such a constraint for them. So we took our mini OEM, basically cut it in half, and we made this guy, the Nano OEM.
Oh my gosh. So that's like that half the size of an ear pod?
Yeah, exactly right. That's
Okay.
right. And really the only difference here is that it's a single antenna. And it often works well. We even have a system integrator that we work with that uses the Mini OEM on the drone side, but actually has created a really cool little controller on a Steam Deck, but uses our Nano OEM on the controller side, just because of the available power to run from the Steam Deck to run the radio. So it's also really that you have that configuration or flexibility of configuration based on what you're building and ends of the network. But then going from that, we have some customers who kind of need like a semi-fabricated option, where they're not going all the way into their machine and installing the radio, or they are, but they also need additional options available to them in what they're doing. And that's where our OEM module came in.
Now, is that like the size of an iPhone or smaller? It looks smaller than an iPhone.
It's smaller than an iPhone. I have an iPhone 12 mini, and it's smaller than that.
Okay.
By height, maybe like a similar width on it. And really what you're getting by going for this is actually it's a dual radio. And by that, I mean it has one Mesh Rider radio on there, which is our proprietary radio that creates the Mesh Rider network. But we've also included Wi-Fi hotspot. And the reason for that is you have really just dynamic network configurations that we see our customers trying to do. And sometimes you have an end user device like a phone that you want to bring onto it, or someone who needs to come in and configure, or even in the testing environment where you just want to be able to see what the system health is or performance in this maybe more ad hoc way. That Wi-Fi hotspot makes it really flexible about the devices that you can bring onto the mesh network.
Awesome. So, hey, Amal, I neglected to ask you, we're looking at the size, and that's a very visible thing. What's the weight differential between, let's start with the Mini that you told us about first, because we're talking about size, weight, and power both, or all three. So the Mini, which is like your ear pod size, how much does that weigh? Like how much weight does that add to a vehicle or to a controller?
That's a good question. I don't have my data sheet right in front of me right now, but I remember this being roughly 20 grams.
Gotcha.
22. I would have to follow up with you.
Yep.
Specific ones. We have all of this information available on our website. We list all of our products and all of these different configurations that we offer. And this is a very important one. So we brought this right up to the front. I just don't have that in front of me. But again, this being half the size is about half of that weight. Well, roughly, because it is this half here.
Yeah, I can see that. That's awesome.
And then this one is just a little bit bigger. We actually had a legacy product of ours called the embedded radio, which was about the size of a deck of cards, similar to this, and is actually being integrated in tons of drone platforms across the world. So it still works really well for these air-based applications. Um, we just know across the board that size and weight and power, reduced power consumption are kind of the main constraints. So we design around that to begin with, and
Yep.
then really look into these additional features that improve connectivity and give you a more advanced network.
Got it. Got it. And you also have like wearable versions or
That's
something?
right. Yeah, I wanted to show you that next. That's this one here. It's our handheld version of the mesh radio. As I was mentioning, it's something that we started from realizing that a lot of these advanced robotic networks still include people. And we wanted to make it easier for these people to come onto these networks. But then actually, as we've also started to enter this space, we have a lot of interest from public safety and industrial workforces that want to maintain connectivity but need to be on something as a private network that we enable, separate from the existing Wi-Fi or LTE network. Or actually, what we're seeing mostly on the public safety side is a network extension feature. So, we work closely with this fire department and have been hearing from them about their what they need out of a mesh radio and why they would use it. And they've explained to us that really their challenge is that they're super well connected in the fire engine. But the moment they get dismounted and go into the field, and they often go, especially here in like California, move into the hills where they go beyond existing cell service,
Right, right.
they're suddenly invisible to the command.
That is downright frightening.
Exactly, and they're working in such dynamic, really sometimes obviously perilous situations. Even when they're doing a search and rescue and there's not necessarily a wildfire, having the ability to run something like ATAC on phone really facilitates an improved and more efficient and safer response. And so when they don't have an available network, this is something where you can basically bring your network with you. And so in a fully distributed environment, the whole team at least stays connected, even if they're not connected elsewhere. But if you use this in conjunction with an existing network, like being connected to the engine where you'd use something like this. So actually, I should explain this part. This back part here is just our battery.
Okay.
You pop the battery off.
Oh, look at that.
And this battery gives about 8 hours of life for this radio. This radio also includes that Wi-Fi hotspot, again, as a way of using your phone with it.
Okay.
Or you could also USB-C tether over to your phone. But this also is fully capable radio on its own. That's just the battery. So you can give it continuous power and mount it in a vehicle like the fire engine. I apologize.
Yeah, I was gonna say right on cue, we're talking about public safety and boom, there we go, the fire engine. So
That's
they
right.
heard you, they heard you, Amal.
Well, and I was going to say, so this kind of thing mounts into a vehicle like that fire engine, and then the team would use it with the battery attachment and take it into the field. That network configuration basically allows the distributed team who could be out of existing network coverage, but using our MANA, still be connected over that longer range, long distance LTE network to a command center.
Well, Amal, I'm thinking about all these expos that we go to where there's never connectivity. Like, strap one of those things on me because I need to be able to do my podcast and stuff better live. And honestly, every time we go, I'm just like, why don't we have a better connection? Might have just solved our problem. Let's talk more afterwards. But all right, so this two-step process, I had it backwards, I guess. Pick your kind of frequency first, right? Like, what are we trying to achieve? And then pick one of these various form factors that fit with the operation you're trying to perform. So is that about right?
One or more, again, like as I mentioned,
Yeah. Plug and play.
OEM, or again, even in the public safety side, we see such a use and capability of drones as an overwatch or to help find like a search and rescue victim. Getting that feed down to the team, that would still be something like the mini OEM on the drone to a team using the handheld version. So they are all kind of like mix and match. And then again, it goes to exactly the thing that you mentioned about the trade shows is just avoiding interference,
Yeah.
avoiding the use of the available band. And that's where multiband again comes in,
Yeah,
where
that's
it gives you just more options in the field.
well, and so great jumping off point to then let's explore a little bit more, who actually is using these in the field. So let's focus first on the defense and government sector. I think you have a partner in PDW and their C100. So I believe we've got a little clip here. Why don't you tell us what we're seeing?
Yeah, that's right. This is performance drone work, PDW. They're based out of Huntsville, Alabama. They're really quite an amazing group of people. And what they're working on is really they're working with our Helix radio. They're using the mini OEM form factor in that M1 through M6 frequency range. And what they have a focus on providing drone technology to defense. And so that's why they're using the Helix configuration. And what we're really working with them, they're great partners, and we're seeing how they're able to use that multi-band capability along with our automatic band and channel switching features to have that improved performance or improved tactical ability in the field. Because in particular, what they're facing with that defense application is actually something that we're seeing a lot of interest and a lot of uh, inquiries coming in from Ukraine as well. We're supporting a lot of Ukrainian-based drone manufacturers because similarly, they're all facing not just interference, but actually jamming.
Yes.
And that's really where you're seeing, again, something like using the spectrum scan, but then seeing where the robot could be operating and just swamping that signal so that you lose connectivity or you lose that video feed. And so having that ability to actually jump over, again, within the band in an automatic channel switching capability, or altogether, say you were up at the upper like 2.5 gigahertz, you can jump all the way down to 1.6 gigahertz and you have a clean link. You have that tactical ability to stay and really use that robot for what you're trying to do. So that's what we see from a defense point of view is what that's facilitating, as well as the fact that defense operations have global deployments. They're going everywhere, and so having that ability to just have one platform, one SKU that you can send wherever, and has that baked into it as a core capability. That's something that we're seeing that's getting a lot of interest right now.
Yeah, and just to foot stomp the fact that this is a Blue UAS framework component, part of the original program
That's
and
right.
continuing into, Blue 2.0. So really cool. And the translation into the commercial sector. So let's talk a little bit more. I think we've got another maybe little clip from Free Fly.
Yeah, and I know I know that we talked about them very briefly earlier on the call, but again, they are a great leader, I believe, on the commercial side of things, and they've done a really great job of providing a solution like that for industry, for commercial use cases, and for that reason, again, they're operating in the ISM frequency bands, the unlicensed frequency bands, and 2.4 gigahertz is an amazing frequency band when you're operating in pretty remote places. The moment you get into an urban environment, you can often see that be degraded quite a bit just from the amount of Wi-Fi devices and things there. And so having that ability to have both both unlicensed frequency bands in 900 and 2.4, which is what we have them using, it gives, again, more peace of mind and really an ability for that end user, that field operator, that drone operator who's already in the field running their mission or running their job of just a surveillance job, having that option for them to be able to have like the most successful use of that drone in the field.
Yeah, and you mentioned earlier, Mal, this idea of dispersed environments, connected teams. I know that's really significant too in so many use cases, whether it's disaster response or preparedness. So I think we've got a little GIF or something to show here. So what do we like?
Yeah. This is actually from AWS and specifically their disaster response team, and they are really great. They're doing something quite interesting. We have this infographic that we use on our website and some trade shows that kind of show this big idea of a really, really dynamic network that includes actually probably all of the form factors that we've made, because they're all use case optimized for different types of systems, different types of robots or handheld. And they've done a great job of actually looking to execute that vision. And so their approach to it is they call it bubbles of connectivity. And so that was a vehicle mounted radio of ours that was on an ATV. It could be on any kind of thing that would carry some people that would be that distributed or dismounted team that would carry something like that would carry our wearable. What they want to do also is fly a drone along with that team that would be flying something like one of our integrated options, like the mini OEM. And so having that drone fly above, say, a team of 5 people with the vehicle, they're creating that bubble of connectivity that would be adjacent to another rapid response team that, with some overlap on those bubbles, you're just creating this very large ad hoc network. And so what they are doing is they're working with some of the leading NGOs around the world, creating this rapid response type of kit using the wearable, and they're still working towards having the drone be integrated into it, but having that vehicle mounted option. And so we worked with them for a couple of years now, done some really cool trials as well as demonstrations with them. And again, it really overlaps with the same use as the public safety use case, but they're specifically creating a kit that can be used in these disaster response settings where I failed to mention, but a big thing that they have to contend with is, say it's after an earthquake, like just happened in Turkey or things like that, where infrastructure and available networks can really be degraded or lost altogether. So having that ability to bring yours with you gives that team that ability to have, like, again, ATAC or any kind of situational awareness tools with them and be able to reliably use them.
That's so cool. Bubbles of connectivity. I love that for
Yeah.
everyone, and data links for everyone. That's Doodle Labs, everybody. Amal, do you have any other comments before we close?
Just to say that, one, again, thank you so much for having us. This is such a pleasure. And thank you for giving us an opportunity to talk about multiband. It's something we're very excited about. And I hope I was able to share some of those ideas that we have, but we think it just unlocks a lot of things for both our customers as well as the end users. So we're excited to show that. We'll be at Exponential, where we're going to be able to show this off as well. And then if anyone's interested, please reach out to us. You can visit our website. We have all this information available, but we'd love to talk to you.
All right. Thank you so much, everybody. We are out here.